So I hope most of you caught Julie's talk yesterday that went over what Paged.js is, among other things, and how it can be used to polyfill page media CSS and create PDFs in the browser. But today, I want to go into what Paged.js can do to make PDFs that are ready for distribution and also Epubs. So first off, we recently launched, or maybe not that recently at this point, but a few months ago, launched Paged.js.org. It has a ton of great resources just generally on how to use page media, CSS. And it also has a lot more documentation for most of what I'll be going over today. So to start off, I think it'd be useful to fill in a little more on the technical details of how the Page.js polyfill works. And again, the polyfill is the part that is using JavaScript and CSS to enable a browser to do something that it doesn't have the functionality for. So we're taking the W3C CSS page media specs and using this polyfill to make browsers that don't natively support it better. So most of what Page.js does is it takes a page media print CSS style sheet and it applies it to a rendering on the screen. So again, plugging the Paged.js.org website, there's a ton more info on the documentation section about what these page media CSS styles are. But in general, I'm going to assume some familiarity with that. But if not, that Designing for Print is the link to check out. So there's a growing number of ways that you can take HTML and apply page media CSS and create a print PDF. I've gathered the icons of some of them here. Some of them are open source, others are closed source, and many of them are very, very expensive. Some of them are command line tools, and others of them are server APIs, so it never lives on your local computer. And other ones are JavaScript libraries like Page.js. But Page.js is unique in that rather than being a publishing platform, it is just a JavaScript library that fills in the missing parts of the page media spec in the browser. So it can render the print layout of any HTML page just by adding the script tag with the polyfill, and then it'll do its thing and change what was a normal HTML page into the output of a printable page. So a little more on the technical details behind that. Our initial approach for this was to use CSS columns. And CSS columns let us take one flow of text and start breaking up the text into page-sized chunks. Columns are used by many e-reader applications like iBooks on your laptop. And we also found that Chrome was using the same column layout code for its actual print page pagination as the screen column fragmentation layout. That's a lot of words at once. But what we're noticing is that if something breaks one way in columns visually on the screen, it will break the exact same way when you hit print in Chrome. So we thought that this approach was a pretty good way for getting print parity between what we were rendering on the screen and what would happen once you hit print. But the big catch was that we can't adjust the size or the position of the columns in CSS. So we created this hybrid approach to fragmentation, and we've been calling that the chunker. The chunker parses the text to layout from a string or a DOM element on the page, and then it renders out that document element by element into a div that's laid out with CSS columns. And it's checking the whole time as it's laying out each element if there's any text that has overflowed into the second column of that document column. as you can see in the little red section there. And if it does detect there's overflow, it'll remove that text by wrapping it in a DOM range and extracting it. And then it'll pass that text location back as something we've been calling a break token. So then the next page, which is a completely separate div containing all the information for the page, starts rendering from that break token. And each of those pages is broken up into the different page media margin zones. So you have the page area with the main flow of the text, and then like the top center that has the title. And we recreated the labeled grid that you're seeing there using CSS grid and Flexbox to construct our polyfill of the contents. And each time we create a new page, we create all of the marginalia boxes for it, start flowing content in, and then adjusting the CSS to go into the right area. So we're rewriting all of the page media CSS that we come across in the style sheets that are provided to the HTML page. And we're then, so we take it out, we translate it to something we can lay out in the flex boxes in the grid as we showed, and we're calling that process polishing it. So there's a polisher, and in this instance that's on the screen right now, the polisher goes in and it replaces calls to CSS generated content, which is getting the page numbers there. And then it uses variables in the DOM to represent it. So this enables creating tables of contents and labels and page numbers and footnotes and all of those things in a way that current browsers can understand. And because Paged.js is a JavaScript library and all of the layout and rendering happens in the browser, it's easy to extend it with new functionality just by using some more JavaScript. So we've created a bunch of hooks into the code to make that easier. And we've created a collection of hooks that we're calling a handler that sort of wraps up multiple different hooks into the code and lets you register it as a new way of handling like some CSS property or footnotes, for example, maybe. So all of the polyfills that we've created are constructed out of these handlers. And if you have your own handler for something you need to do specifically, you can just register a new handler to Paged.js, and it will start rendering the page with that. There's a bunch more examples of sort of things that are handlers that are a little more experimental on the tools/experiments GitLab below. I highly encourage you to check them out. It's a lot of the more interesting stuff that we've been doing with Page.js. Thanks for putting the links into the chat, Julian. So putting all these polyfills together allows us to preview a printed page before we actually generate a PDF. And this was one of the things that during the start of this project we were really excited about as something different from, say, the Prince XMLs of the world. So we've integrated Page.js with Editoria, which maybe you've been to a session on or you're aware of already. And it has a little style editor. And as you edit the styles in the style window there, you can see the live updates without us having to go out and generate a PDF and display back to the screen. It's just reparsing the CSS there and displaying the result. And then of course, once you're done making all your edits, you click print and it generates the final PDF. But everything I've shown so far is just the rendering phase of Page.js, so deciding where elements should be placed on the page. But the PDF as a format is surprisingly, at least surprising to me, enormous amount of features for something that going into this project, I just sort of thought of as a print display file format. It does much more than just have static output. So it can have links and annotations and forms and password protection, to name a few things. And I've heard it even has a few different JavaScript runtime environments in the Adobe Reader that lets you put JavaScript into PDF containers. It's a bit of a mess. So well, we've been making a big deal about how Page.js can display page media in the browser. To handle these PDF file specifics, we've been developing a Node.js-based API and a command line interface to use that API that you can download, run on your local computer, and it will handle the parts of the PDF that don't really belong in a browser environment. And you can call it here. So you say Page.js CLI, you point it to an HTML file, you tell it where the output is, and that will give you the most simple result of transforming that HTML file into a PDF. So I'll let this animation type it out for me. But the CLI is handling plain HTML files, so you don't need to add that polyfill script tag that I was showing before. And if you're working on your local computer, you don't need it to run any sort of local server to preview these. And of course, it can also fetch a remote HTML file and create a PDF of that locally if you need. So, for instance, I've been using this CLI a lot to test with the files from print.css.rocks, and I'll pull them directly from that GitLab repo and then export the PDF locally to my computer to test with. There's a ton more info on the CLI on GitLab. The URL is tools/pagejs-CLI. I want to make a point that we're specifically trying to work out installation bugs right now, particularly on Windows. So any bug reports around that are extra appreciated, just to let us know how it went installing it. And hopefully that process will continue to get easier. So to go into the specifics of what the CLI is doing, it's using Puppeteer, which is a way to control a headless instance of Chrome. So there's no display to the browser, but it's doing exactly the same thing as if you had opened up a page in Chrome on your laptop. And it will load the HTML page that you pass to it. And then it's going to inject our Page.js polyfill, same as if you had put it in the head of the document yourself. It will wait for all the pages to finish and sort of updates you on which page it is as it's going. And then it'll save out the PDF after everything has finished rendering and also just done any final adjustments in the render pass. It can be significantly faster than doing it in your browser because it's a headless browser. It's not actually displaying anything on the screen. So, for much longer documents, documents with lots of images that are drawing intensive, this can really be the way to go, even if you were tweaking it and previewing it on screen. Just to use the CLI to render out those books can be significantly faster. I wish I had some numbers on that, but I'll get to those. So to get back to the distribution side, once we've generated the PDF of the HTML page with the CLI, then it will start doing some post-processing on the file, on the actual PDF file rather than the HTML page. And it'll add some features that we're missing. We're using pdf-lib, which is a wonderful JavaScript library for parsing PDFs and editing the structure to do this. So the first example I want to show you is meta tags. So if you're placing meta tags in the HTML, like you almost certainly have a title, but you can also have author and subjects, creators when it's modified. We'll grab that metadata from the HTML and put it into the format that the PDF wants it to be, so that if you go into a PDF viewer and look at it, it'll be showing up as created by Editoria in this case, instead of the default says like Google Chrome or something. And of course, I'm getting a call on my phone. Hold on a second. Okay. So one of the things this is useful for too is that we can render a visual representation of bleeds and crop marks onto the screen, which is what you see in the image here. But they're only sort of these visual marks until we set the actual crop boxes in the PDF output, which makes them into marks that any PDF viewer or a printer can understand. So setting the boxes in the PDF also allows for, instead of using our crop marks, to add custom marks in Acrobat or some other pre-flight program that will automatically be put into the correct place, because we've set up all the trim box and the art box and the crop box as the correct location. Okay, so I wanted to get through all of that to explain what we're doing to create PDFs, because that is the primary use case of the CLI and in general the whole library. But I thought it would be interesting for this talk to go a little into what we can do with Epubs as a packaging format for distribution. So we put all of this effort into creating PDFs. Why talk about Epubs? Because I think Epubs are great. They are a open container format, and it's part of the W3C. So there's a way you can go in there and you can voice your opinion about how you want to change. Epubs themselves as a format are made up of HTML files, and they're styled with CSS, which is far easier to debug and create and author and display than the crazy esoteric ways that a PDF is styled. There's far better metadata support. You have lots of DC terms that are easy to get in there, and they're readable by viewers and machines, and lots of other ways of parsing metadata that, while possible in a PDF, are just far more complicated. Like a PDF, Epubs allow for packaging together content and that metadata and all the fonts and all the assets, and distributing it as a single file. In the Epub case, it's a zipped file that has a .epub. And while PDFs also work on lots of devices, there's some really interesting devices like e-ink tablets and lower end devices that are able to render Epubs in a way that PDFs sort of fail at. It adapts to a lot of screen sizes. It adapts to a lot of different performance metrics. You can use CSS to turn on and off certain features depending on the device. So in a lot of ways, I think the Epubs are a very ideal packaging format for distributing documents that are created in page media in ways that I don't think PDFs quite are. And I want to pause here for a minute to say that, of course, PDFs rule this space. We're not thinking of really replacing PDFs in anyone's pipelines. So what I'm showing from here out, at this point, they're just experiments. They're a hope. There's something I think that in the future, in a more open ecosystem, could really take off in a way that to me makes a lot of sense. But again, this is sort of future hopefulness rather than in experiments, rather than concrete suggestions for your post-processing pipeline or whatnot. And it's also at this point that I should probably acknowledge that I work on rendering Epubs at Scribd, and that the main open source project I work on outside of Paged.js is Epub.js. and I know I struggle with naming things. But if it's not clear, Epub.js is a JavaScript library, kind of like Paged.js, for parsing and displaying Epubs in the browser. It'll take an Epub input, whether that's zipped or not, and it gives you a set of tools for displaying it and interacting it and navigating it in JavaScript. It's been used in a wide range of readers, from library readers to 3D models that have text next to it. People have done lots of cool things with it. And I'm going to show you one more cool thing to do with it. So the first use of Epubs I wanted to show is using the Epub as the source material for printing. So let's say we're using Editoria and we go through the process of collaboratively writing this document. And then we finally want to export something to go send to someone else as the concrete finished document. In this case, it could be the Epub file rather than the PDF file. So as an example for this, I put together a site at marginalia.press, and just a demo site, so I'm sure it will get easily overloaded. But if you have an Epub, you can drag it onto there, and it will do its best to apply a sort of fairly generic style sheet to that ebook that includes page media styles and render that out. So you can preview what it would look like printed, and then, of course, if you're in the browser that supports it, which Chrome is particularly good at supporting certain page media attributes, you can hit print in it and get a PDF out. So I have a little video of this, and let's see if I can get that to play. So you drop an Epub there, and it starts rendering it page by page. So it's rendering the top pages before the second ones come in. You can kind of navigate through it. There's a table of contents, which I guess I'm not going to show in this video. And then you can hit, I think I just hit Command P there, and it will save out that content as a PDF that you could print. So I've chosen in this default style sheet to put some basic marginalia elements in there. If you were doing this in a serious production environment, it would probably be a style sheet specific to your book that makes much more sense for the content in there. But this just puts whatever style sheet I have around on it. So I made that demo a little while ago, and I was thinking it would be just as interesting to try and do the opposite. So that is, create the Epubs from the HTML using page media CSS for the layout. So rather than having a PDF in between as the sort of canonical source, you could have the layout saved out in an Epub in one of the pre-paginated pages. So this is a different style of Epubs where the text doesn't flow between each page, but you've defined a page style and said, within this height and width of a page, I'm going to lay out each of the elements. This is used typically for textbooks, like the National Geographic's one you see there, where there's pictures and text flowing around the pictures, and a layout that wouldn't be possible unless you fixed the actual size of each page. And there's also a lot of use for this on comic books, where the page is pretty simple. It's usually just an image or some text. Or children's books. I've recently seen a few fixed layout children's books where different elements on the book are animated. For instance, the leaves in this comic could be animated using CSS animations, and so they sort of flutter around in a nice little way. These can look really great, but they're, of course, much more complicated to produce than a reflowable book. So I think there's a big potential here to be able to define the structure of a book like this using page media CSS. So to be able to really fix things on the page without having to go in there and edit, each line of CSS by itself, or to open up InDesign and drag things around for each page. So to back up a second, today with the CLI, there's an option that is sort of a secondary option where you can pass the --HTML flag to the CLI, and instead of popping out an Epub as a result, it'll give you that HTML page that would have generated the PDF. So primarily this has been useful to me for debugging, why certain things are not in the right place. The end result is sort of this huge output of CSS and styles and divs that are what would make up the PDF in the end result. And I was sort of thinking, well, what if I could take this HTML output and create one of those pre-paginated fixed layout Epubs from each of the pages in that. So as an experiment, and only an experiment right now, there's a Epub branch on GitLab that contains a Epub flag rather than an HTML flag. And when you pass it this flag, what it's going to do is it'll load the HTML contents in. Just like the HTML flag or the PDF flag, it's going to render the Paged.js into that page, insert it rather, and render out the whole page in a headless version of Chrome. It gets that HTML back, then it splits the pages in that HTML output into Epub chapters, and because it's fixed layout, each page gets its own chapter. During that process, we start capturing all the assets that were used in the book, so any images or fonts, we pull those out and save those. We fix up the links, and then we generate an Epub package. So that includes the metadata, just the same as the PDF, but also a table of contents and a Epub page list. It includes a manifest, which has everything that makes up this document, so that if I hand it to you, you have all the fonts and all the images. And finally, it outputs a zip of that file as Epub. So to test out this experiment, I'm using the Editoria handbook that we created during a book sprint. The idea was to sort of dog food using the Editoria platform and Page.js for the PDF output. And I believe it was I can't remember if it was 24 hours exactly, but we spent about 24 hours designing and writing and creating this book. 48, I think, maybe. Anyway. So yeah, 48. Thanks, Julian. It felt like 24. It went really fast. So the output of this crazy book sprint that we did in San Francisco, which was probably about 2 years ago now, were some physically printed books that we had printed overnight after we finished this, and a PDF, which you can see on screen there, as well as an Epub. So those two were created by Page.js, the printed book and the PDF. And the Epub was created through the Editoria interface. Well, they were all created through the Editoria interface, but Page.js had nothing to do with the Epub. And I should say the Epub looks quite nice. It has nice styling. It reflows well. But we worked so hard to implement page breaks and nice styles and really high quality images saved as SVGs. It was sort of a shame that the PDF output gets all of this attention and the Epub output is just sort of a flow of text. So I ran this book through the CLI branch there, and let me play this video of there's just a normal Epub file. I threw it on the iPad, and it really renders quite nicely on a fixed size device. So it's the device knows the page size, and so it will scale it to fit the entire page. It has all the images in it. It has the nice table of contents that we designed. You can zoom in and out of it. It ended up on a fixed size screen looking a lot better than I initially expected it to, because I the sort of thought of this. It's a bit of a silly way to make a ebook that's quite as text heavy as this one. And you can also see it rendered by Epub.js on the link below that I will put into chat afterwards. And so this will render this on your browser. It looks like just about any other ebook like this, but you could imagine displaying it in a more PDF-centric fashion where all of the books, all of the pages are vertical, and you sort of infinitely scroll on new pages, and you can zoom in and out. That would be just as easy to implement as this sort of default viewer. And if you want to try out the Epub on some other reader you have, you can also download it from Amazon. AWS, I should say. It's not really on Amazon. And I'll share this link afterwards as well. So one of the things I was worried about going into trying this out is that the polyfills that Paged.js uses require a pretty high level of CSS support. So it has to be able to support CSS grid, which lets us put the marginalia, as well as flexbox, which lets us expand and contract as we add content to those different boxes. It needs CSS columns in order to do the fragmentation. And so once I had this Epub generated, I wanted to try it out on a few different devices, and one of them is this Android ebook reader I have. And honestly, I'm pretty surprised about how well it handles on a device like this. Obviously, you're not seeing the fixed layout marginalia, but for any CSS that it doesn't understand, it being the book's reader here, it just ignores it. And so essentially it falls back to rendering just the reflowable text of the book. So, there's one other thing I should mention is Epubs have an idea of multiple renditions in them, where you can essentially stuff two different Epubs into one wrapper. So you could have one fixed layout book like this, and one completely reflowable book for other devices within one Epub you distribute. I don't know of any ebook viewers that support that, but I think it's an interesting thing to consider that you could ship both of those equally in the same Epub wrapper. And I also think in the future that we could sort of bake the contents that Paged.js puts out into place at the end of the rendering. So now that we know where everything should be on the screen, we could go back and replace it with CSS that we know that a device like this would support. Though I'm not sure an e-ink reader would ever want more layout than is displayed here. So all of that is to say, this was a pretty simple example. It's just text and images. But as Julie showed in her talk, there's really and Greg as well, there's very complex layouts that you can do with page media. And you have full screen images, you have maps and interfaces and that kind of thing. And a lot of that would be possible to capture in a fixed layout Epub in a way that a reflowable one wouldn't really be able to handle. So while at this point this is sort of a silly
We can't hear you, Fred. Hey. Try again, Fred. Nope, 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 nope. Still nope. Just remove everything. Or maybe you need to get off the call and come back. So I wish I had a ukulele so I could play something, but I can't.
That seems to have fixed it.
Yay.
Okay, let me share my screen again. I'm amazed we managed to get through so much before that happened. I like the idea of Julian dubbing me. Okay, so now that you can hear me, why not use PDFs? If you'll permit me to rail on that for a bit. I find the Epub is much easier to assemble. It's a better display on different screen sizes because it can adjust the content a little bit within the dimensions it's given. It's way better way to package assets and fonts together. I find the PDF way incredibly complex. It has much better accessibility by default. You can make a PDF quite accessible, and you can make an EPUB not very accessible. But as a starting level, the EPUB is in a much better place, and it can also be much more secure. There are tons of issues with PDFs being the sort of vector for various viruses and malware getting onto people's computers. So going through what I've used a PDF for, I think we're really left with the PDF is a excellent way to communicate with a PostScript printer. That's sort of its origins, and it's still a good way to get something printed. But I think with some more refinements on tools like this, we could create a pipeline where the PDF is just right at the end of the pipeline, right before sending it to print. And all of these other steps in the distribution process could maintain all the advantages of using HTML and CSS and Epubs. And just to mention, all of this, basically everywhere I've said Epub, this all equally applies to the future work of the W3C on web publications or, whatever Epub 4 might happen to be. Generally, my main message to say here is that HTML can really provide these very paginated views that we're accustomed to using PDFs for, and I think in the future it could be really interesting to try and hold the PDF generation to a little farther down in the pipeline. So thank you. Sorry about the microphone interruption, but I hope you will join on Mattermost and continue chatting about this. I hope you can tell I'm pretty excited about generating these EPUBs from the CLI, and while it's just an experiment now, it's definitely something I'm gonna keep working on, and so stay tuned on Mattermost for when it's possibly more usable. All right, thank you all. I also realized my webcam turned off when I restarted, so